Hello friends, welcome to Success Hub Media. This is Mathematics Made Easy series. This is part 7 of the series where we are learning the secrets of becoming a genius in mathematics. In today's lesson, we'll be talking about LCM and HCF. If you are new to this channel, please like, subscribe and press the bell icon so you can be notified automatically whenever a new video is released. A quick recap of lesson 6, which was our last lesson, shows that we learned about fractions. In that lesson, we explained why you need to know fractions, what fractions are, types of fractions, and conversion of fractions from one form to another. We are not done with fractions yet, but the question now is, why are we digressing to LCM and HCF? We are digressing to LCM and HCF because LCM is a prerequisite knowledge you need to have in order to understand the next part of fraction which we'll be moving to, which has to do with addition and subtraction of fractions. So in today's lesson, we'll be talking about LCM and HCF. In order to have a good understanding of the topic, we will take a look at what LCM and HCF are, why you need to know LCM and HCF, then we will end up learning how to find LCM and HCF. What are LCM and HCF? LCM stands for lowest common multiple and HCF stands for highest common factor. Why you need to know LCM and HCF? If you are in primary school or basic school, it is a requirement for common entrance examination to secondary schools. If you are in secondary school or high institution of learning, you need the knowledge to add and subtract fractions, as fractions usually show up in different aspects of mathematics and calculations. How to find LCM and HCF. Example 1. Find the LCM and HCF of 12 and 18. The first thing you do is to write out the numbers which you are looking for the LCM and HCF. Sometimes all you need to do is just look for the LCM, as in the case of addition and subtraction of fractions. But the main reason why we are learning HCF in addition is because the same procedure you would use in finding LCM is almost the same step you would use in finding HCF. So why don't we just learn them together? And so you know how to find HCF all the same. Okay, so you start by writing out the numbers horizontally like this. Even if they are up to 3 or 4, you write out the numbers horizontally like this. But in this case, we are just talking about 12 and 18. The next thing you do is to draw vertical lines. Draw vertical lines across the numbers. So if there were to be a third number here, we would have drawn another vertical line at the end of the number. The next thing is to draw a horizontal line underneath the numbers. Then you will ask yourself, what is that smallest number that can divide any of the numbers you are considering without remainder? When you are trying to think of that number that you would use as the divisor, you will start from number 2. You will ask yourself, is there any number among these numbers I'm considering that 2 can divide without remainder? Peradventure there is none. You move to the next number, which is 3. Ask yourself, is there any number here that 3 can divide without remainder? If there is none, you move to the next number 5. So you would want to ask why I skipped number 4. I skipped number 4 because any number that is divisible by 4 without remainder is equally divisible by 2 without remainder, and will prefer the smallest number, which is 2. So take for instance 12 for example. 12 is divisible by 4 without remainder, and at the same time is divisible by 2 without remainder. So instead of using 4, we'll prefer to use 2. So peradventure, there is no number that 5 can divide without remainder. The next number you might want to consider is 7. So why did we skip 6? We skipped 6 because if there is any number that 6 can divide without remainder, 2 can equally divide that same number without remainder. If there's no number that 7 can divide without remainder, you might want to consider 11. So why did we skip 8? If there's any number that 8 can divide without remainder, 2 can divide without remainder, right? Why do you skip 9? if there is any number that 9 can divide without remainder, 3 can equally divide that number without remainder. Why did we skip 10? The same rule of 2 applies. So that is how you keep on thinking till you get the right number. But in most cases, even before you think between 2 and 5, you end up getting the number. So like in the case of 12 and 18, already we can see that 2 can divide 12 without remainder, and you can equally divide 18 without remainder, but we are just interested in one of them. So we'll end up writing 2 here as the divisor. Okay? So when 2 divides 12, we'll have 6. When 2 divides 18, we'll have 9. We have 9, okay? Now we have 6 and 9. The same thing you did here is the same thing you repeat here. Ask yourself, what is the smallest number that can divide either of the numbers you are considering without remainder? Looking at 6 already, we know that 2 can divide without remainder. So we'll end up writing 2 here. So you can decide, okay, you end up writing 2 here. Now, you can draw a horizontal line underneath for neatness of work. So when 2 divides 6, it can divide without remainder, right? We are going to have what? 3, right? How about 2 dividing 9? Is there a remainder? Yes. 2 will divide 9 4 times with a remainder of 1. Because there is a remainder, we don't want to have a remainder. We'll bring this 9 downwards. Why are we bringing 9 downwards? It's because 2 cannot divide 9 without remainder. But 2 can divide 6 without remainder to give us 3. So we'll end up writing 3 here. We'll be bringing 9 downwards because when 2 divides 9, there will be a remainder. Hence the reason why we have 3 and 9. So the same process you repeated at row 1 and row 2, the same thing you repeat here. Ask yourself, what is the smallest number that can divide either of the numbers you are considering without remainder? We can start with 2, just like we've already discussed. Is there any number here that 2 can divide without remainder? No. The next number to consider is what? 3. Yes, you got it right. 3. Bravo. So when we use 3, we can see that 3 can divide 3 without remainder. So already 3 is an option for us to consider. It doesn't matter whether 3 can divide the next number without remainder or not. So far, it's the smallest number we have seen, which can divide any of the numbers we are considering. So we'll write 3 here. When 3 divides 3, we'll have 1. When 3 divides 9, there will be no remainder, right? Good. When 3 divides 9, we'll have what? 3. That's the reason why I write 1 and 3 here. So the same thing you did here is the same thing you will do here. You will ask yourself, considering these numbers you have now, what's the smallest number that can divide without a remainder? I know you might be tempted to say 1. No, 1 is not among the options. You start from 2 and you move upwards. So is there any number here that 2 can divide without remainder? No. How about 3? Yes, 3 can divide 3 without remainder. So we'll write 3 here. Take note, when it comes to LCM, there is something special. When it comes to LCM and 1, there is something special. When 3 divides 1, it's ordinarily supposed to be 0 point something. But in LCM and HCF, we repeat the 1. We just bring the 1 downwards because we know it is not divided without remainder. So the general idea is that if there is any number we are using here, and if there is any number that we are considering that the number here cannot divide without remainder, just bring the number downwards. So in this case, 1 falls in that category. That's the reason why we'll bring 1 downwards, okay? And when 3 goes into 3, we'll have a 1. So this is how you will know that you have come to the end of the LCM and HCF you are considering. By the time you have ones, all ones, you can see 1 and 1, right? By the time you have all ones at the end of the table, you know that you have come to the end. So in order for you to calculate the LCM of 12 and 18, you will have to consider all the divisor you have used. Hence the reason why we have the red arrow here. So we are going to consider 2, 2, 3, and 3. We are going to multiply them together. Hence, the reason why LCM will be equals to 2 times 2 times 3 times 3, which is all the divisors we have used, giving us 36. How about HCF? In order for you to find the HCF of 12 and 18, you don't need to do anything special. This whole table you have here is what you will put into consideration. So you start by checking row by row, and you ask yourself, is there any row that the divisor we used divided all the numbers we considered without remainder? Looking at this first row, you can see that 2, which was our divisor, divided 12 without remainder, we had a 6. 2 equally divided 18 without remainder, we had a 9. So it therefore means that this row falls in that category. Hence the reason why we have this green arrow here. Looking at this next row, does this 2 divide the numbers which are 6 and 9 without remainder? The answer is no. Yes, 2 divided 6 without remainder to give us 3, but 2 could not divide 9, hence the reason why we wrote 9 here. So in considering HCF, this row is not an option for consideration. We move to the next row. We use 3 as a divisor here. Did 3 divide the numbers we are considering without remainder? Yes. 3 divided 3 to give us 1 without remainder. And 3 equally divided 9 to give us 3 without remainder. So this row is a row for consideration. We move to the next row. Did 3 divide 1 without remainder? No. That was the reason why we brought down 1. So this row is not up for consideration. So to get our HCF, these are the 2 rows. So it is the divisors that we use in these cases that you are going to multiply to get your HCF. Hence the reason why the HCF in this case is 2 times 3 to give us 6. Let's take a look at another example. Find the LCM of 10, 15, and 20. So we'll repeat the same process we repeated earlier on by writing out the numbers we are considering. Next, we draw horizontal lines across the numbers. Then we'll have, hence we draw vertical lines across the numbers, I meant to say. Then we'll draw a horizontal line underneath the numbers. So you will start again. What is the smallest number that can divide any of the numbers we are considering without remainder? Obviously, 2 can divide 10 without remainder, so we'll start with 2. When 2 divides 10, we'll have a 5. When 2 divides 15, there will be a remainder. Hence the reason why we'll move 15 downwards. When 2 divides 20, we'll have 10 without remainder. As you can see, 2 into 10 is 5. 2 into 15, there will be remainder, will bring down 15. 2 into 20 is 10. So consider again, what's the smallest number that can divide here without remainder? Obviously is 2 because there is 10 here. Okay? So when 2 divides 5, there will be a remainder. When 2 divides 5, there will be a remainder. We end up bringing 5 downwards. When 2 divides 15, there will be a remainder. We end up bringing 15 downwards. But when 2 divides 10, there is no remainder. We'll have 5, right? We end up writing 5 here. So as you can see, 5 has been brought downwards, 15 has been brought downwards, and we have 5 underneath 10. So you consider this set of numbers again. What is the smallest number that can divide any of these numbers without remainder? I know you might be tempted to say 5 because 5 can divide 5 without remainder, 5 can divide 15, and 5 can divide 5. But it will be a wrong approach because we said we always prefer using the smallest number. If you take a look at 15, you'll find out that 3 can divide 15 without remainder. Hence the reason why we will have a 3 here. Now, when 3 divides 5, there will be a remainder, so we'll have to bring down 5. When 3 divides 15, there will be no remainder to give us 5, right? We'll write 5 here. When 3 divides 5, there will be a remainder, so we'll bring down 5. So we have brought down 5, we have brought down 5. Then underneath 15, because 3 divided 15 without remainder, we wrote what the answer will be, which is 5. Then when 3 divides 5, there will be remainder. We have brought down 5 as well. Now we have these 3 sets of numbers. What is the smallest number that can divide without remainder? If we start from 2, is there any number here that 2 can divide without remainder? No. 3, is there a number here that 3 can divide without remainder? No. 4, is there a number here that 4 can divide without remainder? No. 5, yes. Obviously, 5 can divide 5 without remainder. Okay? So 5 into 5 will give us 1. 5 into 5 will give us 1. 5 into 5 will give us 1. As you can see, we have all 1s. We have 1 in all the columns. It therefore shows that we have come to the end of the LCM of 10, 15, and 20. So in order for us to get our LCM, we are going to consider all the divisors here by multiplying them together. So LCM is 2 times 2 times 3 times 5 to give us 60. How about HCF? Just the same way we explained in the last example, we will start considering rows by row by row, and ask ourselves, in considering this first row, did 2 divide all the numbers without remainder? The answer is no. 2 divided 10 without remainder to give us 5, divided 20 without remainder to give us 10, but it couldn't divide 15 without remainder. Hence, we are not considering this row. Move to the next row. Did 2 divide 5 without remainder? No, we brought down 5, right? So we cannot consider this row. Move to the third row. Did 3 divide the numbers here without remainder? Yes. Did it? No, actually, because we brought down 5, right? Very good. So this row is not up for consideration. Okay? So move to the next row. Did 5 divide all the numbers here without remainder? Yes, it did. Hence the reason why we are considering this row for HCF. So our HCF is equals to 5 because it was only this divisor that gave us our HCF. Had it been we had any other one, we would have multiplied them together. So our LCM is 60, our HCF is 5. Moving to the third example, find the LCM of 4, 6, and 8. So we'll start by writing down our numbers, which are 4, 6, and 8. We draw our vertical lines, and thereafter draw a horizontal line underneath. So we'll start by considering the numbers by checking what can divide without remainder. Obviously, 2 can divide 4 without remainder, so we don't even need to start thinking too far. So we'll write 2 here, and when 2 divides 4, we'll have a 2. When 2 divides 6, we'll have 3. When 2 divides 8, we'll have 4. Okay, moving to the next row. We'll ask ourselves, what can divide without remainder? Obviously, 2 can divide 2 without remainder, hence the reason why we have 2 here. So when 2 divides 2, we'll have a 1. But when 2 divides 3, there will be a remainder, hence the reason why we'll bring down 3. When 2 divides 4, it will be a 2. So we have 1, we have brought down 3, then we have a 2. Okay, considering these numbers, what can divide without remainder? Obviously 2, because there is a 2 here. So when 2 divides 1, it will be a fraction. We don't want a fraction, so we'll bring down 1, okay? When 2 divides 3, there will be remainder, so we'll bring down 3. When 2 divides 2, we'll have a 1. Hence the reason why we have brought down 1, we've brought down 3, and we have a 1 here. Now, considering 1, 3, and 1, what's the smallest number that can divide without remainder? It is 3. When 3 divides 1, it will be a fraction, so we'll bring down 1. When 3 divides 3, we'll have a 1. When 3 divides 1, there will be a fraction, so we'll bring down 1. So we end up having all 1s. So we have come to the end of LCM of 4, 6, and 8. So in order for us to get our LCM, we'll multiply the divisors together. So our LCM is 2 times 2 times 2 times 3, which is 24. So in order for us to get our HCF, we'll start considering row after row. Checking the first row. Did 2 divide all the numbers without remainder? Yes. So 2 is up for consideration. Did 2 here divide all the numbers without remainder? No, it couldn't divide 3, so we will not consider this row. Moving to the next row. Obviously, there is a 1 here which 2 did not divide, so this row is not up for consideration. 3. There is 1 here which 3 could not divide, so it is not up for consideration. So our LCM is 2, because it was only 2 here that divided the numbers under consideration without remainder. So our HCF is 2. Alright, so Try the following. You can write your answers in the comment section when you are done. If there is any part of this tutorial that you don't understand, you can let me know in the comment section so I can throw more light on the area you don't understand. And if there is any topic in mathematics you would like me to make a tutorial on, let me know in the comment section. If you find this video interesting, there are more on my playlists. You can check my channel. Don't forget to like, subscribe, and press the bell icon. Thank you for listening. Till we meet again.